Just out of curiosity, how many of you have heard of Sitecore before the session? Okay, this is great. That's kind of what we prepared for. So I'll save the material for when we reach it. But this is our talk about MongoDB and how Sitecore relies on it for better performance and better scalability. And I'm Grant Killian.
And I'm Antonio Giannopoulos. I'm a database administrator for ObjectRocket, and my specialization is Mongo. And Grant is a Sitecore architect, so his specialization is Sitecore. We put those two things together and we created this presentation.
Right. So you want to do the agenda?
Yeah, so we're going to discuss some key terms first, because none of you is familiar with Sitecore. Grant will describe a little bit what Sitecore is. A small introduction to Mongo, like key terms like what's replica set, shards, blah, 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 sharded clusters. And then the main presentation, best practices for MongoDB and Sitecore. We're going to discuss scaling for Sitecore. And in the end, we're going to present you some benchmarks that we did for Sitecore and MongoDB.
Cool. Yeah, this is really 3 sessions in one, I guess, 50-minute segment.
Yeah, that's us.
That's us? It's a different shirt. It's similar. All my shirts are very similar. So, as I said, this is really 3 talks kind of combined into one. And the first is just enough Sitecore to make you dangerous and help give you context for when we get to the real good stuff as it relates to MongoDB. If there's any questions, this is casual. Feel free just to blurt them out, ask, and we'll do our best as we go. So first off, Sitecore is a content management system. And no talk about some other technology that you're not familiar with is complete without a Gartner Magic Quadrant. So this is the one for Sitecore, most recently as of last fall. And up in the right corner, circled in pink, is Sitecore. There's other manufacturers of technology very similar. Adobe, there's Acquia, Episerver. It's a very crowded market, but Sitecore over the years has really pushed the envelope in many ways, and it's now with MongoDB starting to be even more performant than it's ever been, more scalable than it's been, and that I think is no small part for why we might find ourselves in that upper rightmost leaders quadrant. And the salespeople from Sitecore always love that too. I used to work at Sitecore, so I'm very familiar with their tactics. So Sitecore is kind of like Legos. You can snap it together in lots of different ways to solve technical problems. It runs on Windows IIS web servers, traditionally with SQL Server as the back end, but there's a MongoDB component that is significant to it, and we'll get into that. But for the moment, this slide shows a little bit of the salesy presentation for Sitecore, how you could create an email campaign management solution on Sitecore that would let you target all the emails, say for a conference like Percona. You could target, okay, so this candidate clicked on these links, they're interested in this topic. Maybe when that person visits the website based on the email, we should profile them and send them into a certain department that presents ads that are targeted to them. It's this profiling engine and that logic behind it. That is Sitecore. You can also create e-commerce packages. You can create book catalogs. Really, there's nothing that you can't create in Sitecore. It's more finding the most performant and efficient ways to make it happen. So Sitecore started in around 2000, so it's kind of grown in this Microsoft ecosystem. That's why its dependence on SQL Server for many years was so pronounced. If we look at for you guys, the left-hand side of this graphic, if I don't block it for you, shows like the most simple Sitecore architecture. So we have the red circle is Sitecore's logo. So it's a web server, in this case it's IIS, and it's got a connection to SQL Server, which is the relational database backend for it. As you move from left to right, that's the scaling story with Sitecore. So there's small brands like a university in the Northwest, I won't name names, they would be able to use Sitecore in a very limited fashion. The far leftmost is fine for them. As we move to the right, we could get big multinational corporations. Like every brand of soap you look at on the aisle at the grocery store could be provided by these companies. So they get many hundreds of sites, different languages, different versions of content based on times of the year. Very elaborate sort of systems, and for them, the most they could scale would be, I guess, X number of web servers, and then 4 SQL servers, and that is a hard 4 SQL servers. So you can make these really big SQL servers, but there's a limit that you can hit. And that was a scalability problem. And I know at Sitecore, as I was talking with you earlier today, we would get involved with engagements for some of these very large implementations that are running up against that block, and the first thing we would do is start to disable features that we knew to be the least performant in order to get them past these bottlenecks. That's not a winning story for Sitecore, and so they found MongoDB to be a remedy for that problem. So you'll see now the most simple Sitecore implementation still has a MongoDB component, and that's a real logical MongoDB. It's not a single replica set, it's not a single anything. It's really just the presence of a MongoDB endpoint through connection strings that are defined. And then as you move from left, which is the most simple, to right, which would be the biggest, more complex, highest throughput, that sort of thing, you still have this MongoDB presence. Whoa, that's dramatic.
Oh. What happened? Sorry about that.
That's good.
Oh, it's back.
Cool. And so they can get past this bottleneck of having only 4 SQL servers that they can use. Instead, they can open this up with a single MongoDB connection, which is virtually limitless in terms of its scalability. Yes? Am I going to get into why 4 SQL Server databases? I don't think I do. I can just quickly. The reason it's 4 is because the way Sitecore is organized internally, there's like a runtime staging environment where all the settings and like security, user accounts, that sort of stuff, that's one of the databases. There's another database that is for all versions of all the content in all languages. So you can imagine if you've got 30 languages that you're targeting for a global brand, there's lots of content. And if it's been around for 5 years, they may have hundreds of versions of press releases and all sorts of materials. So that's one of the other databases. The third then is the runtime live database, which is the current version that's in production that's viewable to the public. So you don't care about historic versions. You don't care about things that are not published. So things get promoted from one of those SQL servers to another. And that's how you get the 3 SQL Server databases. The 4th SQL Server database that is not present here now is analytics. And that's this system which I will talk a lot more about, actually. So the reason my daughter insists I put an emoji in a slide, so I get extra credit for her. The reason that Sitecore selected this NoSQL database store was because that analytics system that they have when they're profiling a customer at an e-commerce site, and say I do a search on the word salsa, and it pulls back search results related to salsa. Maybe there's salsa dancing, maybe there's salsa food, maybe there's anything that matches that result. The Sitecore engine is storing the fact, hey, this person's interested in this aspect, this salsa thing, and you can set your Sitecore relationships up so that maybe the next time I come to the site, weeks or months later, it still remembers, hey, this person likes salsa. Maybe we should present them information on traveling to Latin American countries or books about how to cook Spanish food, that sort of thing. But it's different for each customer, and that difference requires a flexible schema. Not all customers are alike. In fact, you would almost say almost every customer is different. And that analytics database is that 4th SQL Server database that Sitecore freed itself from SQL Server with and replaced with MongoDB. So I don't have to make the case to you guys about document data stores and that flexibility, I assume, right? That's given. And there's virtually limitless scalability. I'll let Tonios could caveat that. It's not really infinite, but as far as we're concerned, it pretty much is. And then it's interesting other scenarios that come into play once you introduce MongoDB into a Sitecore implementation, because then, well, instead of using session state in memory on the web server or in SQL Server, we could actually store session state, which is an HTTP tracker for individual visits that every web application has had for 20 years. You can start making MongoDB useful for other systems that maybe previously had been frustrated by having to store data relationally when it really doesn't lend itself to relational database. There's systems in Sitecore external modules that you can slap on now that are starting to add and increase their support for MongoDB. One specific area is web forms, where you create a dynamic set of entry forms for people to complete online, signing up for a newsletter, signing up for a conference, some sort of interaction with the customer where they're selecting inputs and hitting a button and it saves it off somewhere. That's going to be dynamic based on the customer, and it really lends itself to a NoSQL backend. And also this last bullet point is there is a 100% replacement for SQL Server that is strictly experimental, not officially supported, and it's enticing because of you don't pay any of the licensing fees for SQL Server, but it's become one of these other aspects that becomes feasible, at least to consider, and start to think about, wow, this is interesting. Now we've got MongoDB and all these implementations, what else can we do?
Yeah, that's the most interesting. Thank you. Some basic about MongoDB in order to understand how we're going to scale Sitecore in the next slides. Replica sets in MongoDB is a group of MongoDB processes, and they offer redundancy, high availability, and some type of scaling if you're using secondary reads. The replica sets in MongoDB consist of at least 3 nodes. These nodes can be either primaries, which is the node that takes all the writes, and reads if you're using the defaults on your driver. Secondaries is a node that will replicate every CRUD operation that will happen on the primary, and an arbiter that is a node that is just there to vote just in case you have an election on the replica set. You can grow up to 50 nodes if you're running 3.0 and higher. Before 3.0, it was 12. The replica sets are using asynchronous replication, which means the secondaries usually are few operations behind the primaries, and the secondaries are responsible for pulling those operations from the primaries and apply them to themselves. There is an automatic failover mechanism. In case the primary goes down, the cluster will elect a new node as a primary, which would be one of the secondaries. Some best practices about replica sets, really quick. You have to deploy odd number of members, and that has to do with the elections in the cluster. If you have even number, in case of an election, you might have an election that 2 nodes will get the same number of votes, and you will never elect a new primary, so it's not going to be high availability for you, it's just going to be availability. Most probably you need to use the same server specs, and that has to do again with either the elections or the replication. If you're not using the same server specs, if an election happens, one of the nodes that doesn't have the same capacity as primary will promote it as primary, and you'll get poor performance. If this node is a secondary, it might not be able to cope with the replication, so it might stay behind. There is a huge lag in replication. Eventually, it will get out of sync. So most probably, you need the same server specs there. Of course, you need to have a reliable network connection, because if you don't, you're going to have elections all the time. You're going to have interruptions on your driver. And in production, most probably you need to adjust the oplog. The default is 10% of your disk. In some cases, you don't need 10% of your disk. You need less. In some cases, you might need more. That depends on your cluster and backup scenarios, restore scenarios, and how fast your secondaries can absorb the oplog from the primary, things like that. But in any case, you have to adjust the oplog. I mean, you should not run with an oplog that's 10 minutes, for example. Because if your secondaries, for some reason, are offline for 10 minutes, your cluster will become out of sync. Sharded clusters is a mechanism that Mongo uses for horizontal scaling. They consist of MongoS, config servers, and shards. MongoS is the abstract level between the cluster and the driver. It hides the entire sharded infrastructure and presents it to the driver as a single Mongo instance. The config server is where we keep the metadata for our actual data. This is a horizontal type of scaling. So I'm going to have multiple servers. I need to have a common repository that my clients will know where the data live, and that's the config server. And finally, the shards, they hold the actual data, because that's for what databases are for, to store data. And this is an example of a sharded cluster. Here are the MongoS. The client connects here. If he has the information about the request, we'll send directly to the shards the request. If they don't, they will ask the config servers. The config servers will give back the location, and they will ask the shards and return the information back to the client. Best practice again here, most probably you want to deploy the shards as replica sets for high availability. Again, you need reliable network connections. But the most important on a sharded cluster is that you have to choose shard keys, right? There's no point to deploy a sharded cluster without sharding your collections, without your data being not sharded, right? Have in mind that undo a shard key might require downtime here. So that's super important and super critical. What makes a good shard key? We discussed that yesterday on the tutorial very verbosely, really quick. It has to have high cardinality. It should not have null values. It have to be immutable. It should not be monotonically increased. Even read-write distribution must be guaranteed. It has to create an even data distribution, read targeting, read locality. All these are characteristics of a good shard key. In theory, in real world, most probably we don't achieve all of this. We try just to satisfy the constraints, which is not nulls and immutability, and we sacrifice some of the others because most of the times it's impossible to satisfy all this, and that's the ideal. And you have to remember that the most important when you're choosing a shard key is your application. It's not the theory that I'm gonna teach you in the class, right? I mean, it's your application. Really quick introduction to MongoDB engines. Mongo, after version 3.0, supports multiple engines. mmap, WireTiger exist on both Percona server and the community edition of Mongo Inc. And Percona server also includes RocksDB in memory. I don't know if this is still there. It used to be, but I don't know. Just keep RocksDB in memory. Each of these engines has its own characteristics. Like, for example, mmap is super good when you read data. It's not that good when you write because it has collection level login. WireTiger is better on writes than reads comparing to mmap. RocksDB is a database that is super when you're writing data. It writes super fast, but if you run a lot of range queries, you might have an issue. And in-memory storage engine is it's for non-persistent data. It keeps all the data in RAM, so it might be great for use case if you are storing ephemeral data, because if you restart the server, all your data will be lost. That's you, right?
All right, sure.
Yeah. So the in-memory storage engine is the WireTiger storage engine. They just have enabled a flag which is called persistent for every collection that is stored on that engine. The persistent, what it does, it loads all the data in RAM. Okay, so you're still going to use B3 indexes and all the data structures that WireTiger has. So if you think that those data structures are okay for your use case, because I don't think Redis is using B3s, I think it's using lists, right? So if you think the B3s are better, you should use the WireTiger storage engine in memory. If you think that sorted lists or something like that, hashed lists, I'm not familiar with Redis. So if you think that the data structure that Redis has is better for your use case, you should use Redis. But the advantage of this storage engine is that you don't have to change your code. If you are using Mongo as a caching layer, you can just change your underlying engine, and you don't have to alter your code at all. But as I said, it has to do with the data structure.
There's a question here too. Or no?
Oh.
Okay. Or you went back, or I went back, sorry. So Sitecore defines 6 endpoints, connection strings, as it relates to data storage that MongoDB gets involved with. Analytics is the critical one, in my opinion. That's where the most activity takes place. That's where all of that session, all your behaviors that are being profiled on the site, that gets stored in the analytics database. So yeah, as an example, like it tracks your IP address and there's reverse lookups to determine your zip code and your shoe size, all that stuff. It stores it. And then these 3 tracking _star endpoints, those are more used for processing of this data. Tracking contact specifically is used when, so There's a slide later that will show this a little bit more visually. So I'm interacting on this site. I've searched for salsa, I searched for kitty cats, and now I've left my browser session open maybe 20 minutes, and that session has expired because I'm no longer there at the site. So that session data is getting dumped to this analytics MongoDB repository. Then, once that write is completed, the tracking underscore contact database is used to monitor the progress of that data getting map reduced for eventual storage downstream in Sitecore's SQL Server database. You can think of SQL Server being as the data warehouse in that point. So this tracking underscore contact is kind of a scratch system there where it's monitoring the progress, sees everything through, and then you're done. Tracking history is doing much the same as tracking contact, but once in a while, if you make some significant changes or if you have migrations, outages, upgrades, you may need to completely reprocess all the data that's in this analytics database. That reprocessing can take a long time, hours, days, weeks. This tracking underscore history is designed to track all that worker activity, making sure progress has been made, if it has to resume, that sort of thing. And tracking live is another working database for that incremental map reduce work. So these are kind of like internally. They're not super like read or write heavy. It's a small data volume, but they're still important. The last two, private session, that's the classic idea of session state for web servers. Are you familiar with session state when I say this? So I see one person. Anyone else? Okay. So I don't want to take anything for granted. That session state is the server, in this case SQL, or I'm sorry, IIS in Sitecore's case, keeping tabs on all your behavior for the lifetime of your activity on that browser session. So after I've done my search for kitty cat and salsa, and then I walk away, my session ends, and that's called private session. That private session is what gets dumped here to the analytics database. Shared session is a novel idea that Sitecore added into their ecosystem at the same time when they added MongoDB, because they wanted some like a meta session that crosses over these discrete individual interaction points. So that's going to have the history of your interactions with the site. If, for example, you clicked on that email to register for the Percona conference, but then you come back to the website and maybe then you're going to browse for apparel. You can't get enough of these Percona green t-shirts, very fetching. That's an engagement as far as Sitecore is concerned, but that state that crosses over multiple sessions would be in this shared session. So it's like a meta session. I could say a lot more about that. This slide attempts to do that. I don't want to belabor the point. If you'd like me to, we can maybe come back to it, but I'm just going to, rather than read this bullet pointed list, say this is illustrating that flow that I just described. I'll pause if you're going to take a picture of it now, I feel. Are you okay with me moving on from this, or do you want me to spend more time on that? I feel like there's more value later on. I don't want to take up all of Antonios' time.
It's up to the audience.
This is you, right?
Yeah, that's me. So, as Grant said, Sitecore consists of 6 databases. So, you have 6 databases. The simplest way to scale Sitecore is to put its database on a separate instance. It's very simple. You just go to Sitecore and you say, this database, I want to live to that server. Done. The advantages of this solution is that you can optimize each instance according to the database needs. For example, session state might need more CPUs, or analytics might need more RAM because it runs heavier queries and has larger indexes. And if you do something like that, if you put each of the database on a different instance, then you can use polyglot persistent for Sitecore. You can use different storage engines of MongoDB for each of these databases. A very good example is the in-memory storage engine is a good fit for sessions. Sessions are ephemeral data. They're non-persistent. They live in RAM. I mean, Sitecore in version 8.2 uses Redis for that.
Well, there's a provider model, so you could use Redis, Mongo, SQL Server.
Yeah, in earlier versions, you don't have that luxury of Redis for sessions. It's either nproc or Mongo, right?
Or SQL Server.
Or SQL Server. So who wants to save ephemeral data on a database that is made for persistent data? None, right? So you're using the in-memory storage engine and you optimize that database. The ways you can do that is different instances, or you can use a sharded cluster, and you distribute these databases on different shards, and each of these shards have a different storage engine. You can do that on a sharded cluster. Because the MongoS, as I said before, hides the infrastructure from the driver. The driver doesn't know which engine the cluster runs. It only cares about Mongo. Another way to scale Sitecore is to shard the collections. Sharding is there to give you performance, right? So if you shard the collection, you distribute your data into multiple servers, so each server has a smaller data set, smaller indexes, so if your queries are targeted to that specific shard, your queries will be faster, okay? The question about Sitecore was what to shard. That was the first question. So we decided to shard large collections for capacity, because we have to evenly distribute our data on a sharded cluster, right? We don't want to end up with one shard with 1 terabyte, another shard with 1 gigabyte. We want to evenly distribute the data as much as we can. And we have to shard the busy collections in order to achieve the load distribution and get the performance. I mean, just distributing our data is not enough. I mean, if we distribute a collection that might be 90% of our workload, but we query that collection once a week, we don't gain anything. I mean, still, our workload will be leaving the primary shard. The next challenge was how to pick a shard key. We had a class yesterday. We discussed that about 30 minutes. But really quick, the methodology that we used here is we profile Sitecore, we collect all the statements that run against the Sitecore collections, and then we pick shard keys according to those statements. We try to find shard keys that, on the one hand, they meet the sharding constraints, they don't contain null, they're immutable, and on the other hand, they scale the statements. So, scaling for capacity. This is from the Sitecore documentation. 80% of the disk space comes from these two collections. So we started with these two. Collection interactions. We profile all the statements. We find that only inserts, queries, and updates happen against this collection. The read-write ratio is 60 to 40. All the updates, we're using the underscore ID to identify which records to update. The query patterns were 80% using the underscore ID and contact ID. Contact ID and another predicate was another 5%. Contact ID and another predicate, another 15%. So underscore ID was on all of our updates and 80% of our reads. So that makes it automatically a very good shard key. I mean, it's going to scale like 90-something% of our traffic, right? So we're going to have some scatter gathers, like 20% of the queries, but that's fine. As I said, we have to sacrifice sometimes some things on a sharded cluster. We cannot find the perfect shard key. Contact ID was also a decent choice because it will scale all the reads. All the reads contain the contact ID as an exact match. But all the updates will be scatter gather. And additionally, on a sharded cluster, the updates should use the shard key. Underscore ID is an exception to that rule. But if you have underscore IDs that are not generated by the driver and generated by the application, and that means they're not object ID and a value, but they're random values that have been created from the application, you might end up in a situation that the application malfunctions, create the same underscore ID twice, and send these two identical IDs to two different shards. So you end up with a cluster that has two underscore IDs that are the same. It's a possibility. I know I'm paranoid, right? But there's a chance. So contact ID is a good shard key. Just this little tick over there, it was our concern. So most probably, you have to consider also the storage engine. when you choose the shard key for this collection. I mean, mmap, we need to optimize the writes because that's the bottleneck. So underscore ID is perfect because it will scale all the updates and 80% of our reads. So for WireTiger, that we know that the writes is not a huge issue. I mean, WireTiger can handle document level locking, so it can handle more writes per second. We might want to scale the reads more than the writes. Okay. So our proposal to Sitecore for interaction was why you don't include on the updates the contact ID, and then we can have a perfect shard key, right? Because our updates will be on contact ID and ID, and all of our reads have the contact ID already, so making contact ID the shard key will target all of our operations to a single shard. They haven't implemented that yet, but
have they asked you?
Yeah.
Or have you told them?
I will. I will again. And collection contacts using the same methodology, things here were slightly easier because all updates were on ID, all queries were on ID, and some additional fields there, ID and something else. So the shard key here is very easy to identify as underscore ID, right? Some other collections that we shard, we investigate and shard. We end up to the conclusion that the underscore ID or underscore ID hashed is the best shard key.
Can I ask you a question?
Yeah.
So ID hashed versus ID, what would be your calculus and how would you pick?
Yeah, that's the next slide.
Oh, perfect.
Yeah. So yeah, I mentioned on my slides ID or ID hashed. I mean, we all know about hashed shard keys that we're using hashed when our key is monotonically increased, right? We're using hashed in order to create randomness and not all the inserts go to the last partition of Mongo. On Sitecore, I mentioned before that the underscore ID is generated by the application and it's a .NET UUID. An example of ID is this. Unfortunately, you cannot read the UUID here because they bundle the UUID into the binary data type of MongoDB, which is a best practice. They're not doing that wrong. That's a best practice. If you download that script from this location, it will help you extract those bin data and get the actual value back, which is very familiar for people that know about .NET. This is a .NET UUID. So this is the actual UUID that the application produced, and it's not monotonically increased. It's a totally random string. So I mentioned ID or ID hashed. So you're going to use ID when your collection already has data. When your collection is empty, you can use ID hashed and introduce number of initial chunks to your sharding command, which will pre-split your data set. Will create the partitions in advance, which means that you're going to avoid in the future move chunks and split chunks. So that will make your life easier. But you cannot use the number of initial chunks if your collection already has data. So what we do for our customers, if they come with a fresh installation, we use ID hashed and number of initial chunks. If they come with an existing installation, we're using ID. We don't want to add another extra index to their database and waste space or waste performance. How you define the number of initial chunks is this type here. Pretty simple. Since you're going to do sharding for your Sitecore installation, most probably you're going to have more than one shard. I mean, if you shard the collections and you have one shard, it's the same as leave them unsharded, right? So under the assumption you're going to have more than one shard, you can do what we call move primary. So Sitecore has 6 databases. You're going to have more than one shard. Why leave all the databases to one shard? Do a move primary and move some of these databases to other shards. So you scaling Sitecore even further with this technique. Be careful because it requires downtime for live databases. So you might need to do that in advance if you're doing a fresh installation. Don't do it after. You can also scale Sitecore by doing secondary reads. The problem with secondary reads is, as we described, the secondaries are a few operations behind from the primary, so you are reading stale data. In 3.4, they introduce a parameter which is called max staleness seconds, which doesn't allow you to read from a secondary that is X amount of seconds behind the primary. Unfortunately, Sitecore doesn't support 3.4. It supports up to 3.2. But for future versions, this parameter here might be useful for Sitecore installations that they're using secondary reads. A very handy approach for the secondary reads is to use replica set tags. So for example, if you have 7 secondaries, you can tag the first 2 secondaries with the tag analytics, and then you can tell your driver, I want to read for the analytic database only from these 2 secondaries. And then the other 2 secondaries will be dedicated on tracking, the other 2 secondaries will be dedicated on session. So in a way, you don't mix up workloads. You have some kind of workload isolation on your secondaries. The way to do it is described here. And then we had, after scaling the Sitecore, we had another challenge in our organization. We had to deploy multi-region Sitecore installations. It is related to scaling, but it's more like design. The challenges we had is on the multi-region, you have to direct the reads to the closest node. You have to direct the writes again to the closest node. Our customers needed to have a single database entity for reporting, and they asked us to keep the complexity minimum. So the first solution that crossed our mind was replica sets. So we created a replica set, we distribute the secondaries on the remote locations, but the problem is that all writes will go to the primary, and the primary has to be in one location. So if you have Europe and the US, the primary most probably will be in the US because based on the population is bigger. So the writes from the Europe has to travel over the Atlantic and be inserted in the database. And requires at least 1 secondary per region. I mean, if you try to do that with the United States and you want 1 server per state, you're going to need like 50 secondaries. Then we decided to examine if we can do that with sharded clusters. It might be better with sharded clusters than replica sets. Again, we have our shards. We add secondaries per region. So we use nearest read concern. So the reads could go to the closest secondary. But the problem we had here is that we have to send the data for its region to the region, right? On a sharded cluster, you distribute your data according to the shard key, right? There's no implementation on the balancer to distribute the data according to regions. So you can introduce tags and zones, but this must be based on the shard key. And as you saw before, our shard keys are based on ID, right? So how are we going to introduce ranges and, zones and tags on the underscore ID? It's impossible. We have to have another field as a prefix. So that might require to change the source code of Sitecore.
That's 2.
Yeah. So we came up with this solution. We created the Mongo to Mongo connector. Well, we didn't create the Mongo to Mongo connector, we used the Mongo to Mongo connector, which is a pipeline from a MongoDB cluster to another MongoDB cluster. What it does, it's pretty simple. It reads the oplog and replicates all the oplog operations to a remote location. The deployment is very easy. You just download the Mongo connector and you run that command. So this is what the Mongo connector does. There is an insert. It goes to the primary oplog, and the connector here reads the oplog and replicate the insert to the remote location. So we install for our customers the replica set on each region. So all the writes and all the reads were going locally, and the Mongo to Mongo connector was feeding a central database that they were using for analytics. And when one of these regions were super busy and couldn't cope with a replica set, we were deploying a sharded cluster, and the solution was exactly the same. It just needed an extra work here because we had to establish a Mongo to Mongo connector per shard instead of one Mongo to Mongo connector here. And that is what we're working right now. Some of the regions are really, really busy, and this is a single cluster, and it has to get all the writes from all the remote clusters, and sometimes this cluster cannot consume that fast, right? The Mongo to Mongo connector doesn't have throttling. So we're thinking to introduce Kafka queues in the middle, so the Mongo to Mongo connector will send the requests to the Kafka queue first, and this instance here will consume the Kafka queues. So we're not going to lose any writes, and we can throttle the inserts and the updates and the deletes. Up to you. Yeah.
So, like you have multiple replica sets, right? So, from different regions,
Yeah.
right? The cluster, then you assume that they never have conflicts, right? So they're all.
There's no conflict, no, because it's based on underscore ID.
So you underscore the region.
No, the underscore IDs are generated by the framework. They are .NET UUIDs, so they're unique. It's universal, unique numbers. So you don't have any conflict.
It's somewhat based on the timestamp and
That's, I know the dummy ID, but the data itself, right? Is that a user from different regions? There's no the same user?
No, yeah, so a user cannot jump from location to location. That's the problem. But our customers doesn't have that problem. They don't care about that. They don't have remote users. Most of the customers that we have work on. They don't mind if 1% of their user will change location for traveling, flying to another region. They have measured that and they said, that's negligible. We don't care about that.
so we did some benchmarks. Just, we could say a lot about the benchmarks. Maybe in questions we could go into more detail, but suffice it to say, we were confirming that mmap is around 9% slower than WireTiger, just with the single, straightforward, basic MongoDB setup. And it's about the same with the sharded cluster approach. Do you want to add to that, Antonios?
No, just the next slide.
Yeah. Oh, yeah. So this is I guess my attempt to be a pivot, because if you're not working with Sitecore, how is this applicable to whatever it is you're working with? And I think it's very applicable, and a lot of the methodology that Antonios went through to apply these Mongo architectural options to solve this little specific problem for Sitecore is, I would not say universally applicable, but that pattern, that framework for approaching it is very, very applicable. So I would just encourage to evaluate your MongoDB architecture using that same kind of diligence. Like you said, you were running just queries after queries. Don't talk to the developers what they think is the data. Actually look at the data. So if scaling's in order, then we go back in the slide about, 10 or 20, and review that process, that methodology. And also a takeaway I'd recommend is that Mongo's versatility is what made it so attractive for Sitecore, and we're now just starting to uncover, oh wow, there's a whole ecosystem here that we can start to take advantage of and make things better. So you want to do this?
Yeah. So what's next? About the benchmarks, that's why I asked for the next slide. I must admit that our benchmarks were not super great. We had problems with the IIS and the SQL servers.
Yeah, isolating
and stuff like that. So,
just the Mongo parts.
Yeah, we're going to try to improve that presentation by making more benchmarks, and we're trying to identify where other bottlenecks are on our system, because we got really weird numbers on some of the benchmarks, which states that the bottleneck was somewhere else, not Mongo. So What else we planning to do is to test Mongo Rocks as well, because we test WireTiger and mmap for some of the databases of Sitecore. Test the in-memory database, like a benchmark, because right now it's just an assumption that it's going to work faster. We want to expand sharding recommendation for other Sitecore add-ons, and we want to evaluate other Sitecore modules for MongoDB against our benchmarks, and of course reinvent our benchmarks, because as I said, they were good, but they're not perfect. And of course we're hiring. We have our recruiter over there.
And just, if I could interject, so I don't work very closely with the object rocket team. I'm a Sitecore guy.
Yeah.
And so we end up working with them peripherally, maybe 10% of my time. But the sort of work that Antonios did here is applicable to all our Sitecore customers and very valuable, but there's a wealth of other applications, custom ones out there, and the engineers are doing that kind of work. And if that's interesting to you, I guess talk to you, right?
And that was it. Questions? WireTiger was faster, yes. Yeah, well, Sitecore is more reads than writes, so that's why we didn't see a huge boost on performance with WireTiger. We still see a better performance. And if you combine that with the WireTiger compression, WireTiger is going to save you space and money, and it's going to give you a better performance. But you should not expect. I mean, I've seen on the web some benchmarks about WireTiger that says it's like 10 times faster than mmap. Yes, it is, but it depends on the use case. And in this use case, most probably you're going to see a boost on your performance, but don't expect to get like super surprised.
Yeah, our benchmarks were captured through JMeter, which is client side, replicating that whole customer visit, the HTTP request, the network. There's a lot of intermediaries that we want to isolate to really get to the MongoDB.
And yeah, we see that from our customers as well. I mean, most of our customers choose WireTiger because they want to save money because of the compression. And yeah, the performance, it's not remaining the same. They see a little bit boost, but they don't complain, oh, WireTiger is worse. So, yeah.
So before you move into using MongoDB, we explore like other options. Like you could initially use SQL Server. You could have like short SQL Server to achieve the same thing. So why you just decide to go with MongoDB but not having other?
That's for the Sitecore guy.
Sure, no, it's a great question. So why MongoDB instead of these other options is the question. And I worked at Sitecore at the time in their professional services team, and so we were engaged every week with customers experiencing performance problems. And they actually set some configuration settings where you could disable that analytic subsystem entirely, because that was like deflating or popping a blister. It relieved the pressure and performance would return to acceptable levels time and time again. And so that's how they knew to start looking at that analytic system specifically. Why they chose MongoDB instead of some other document-based storage, that I don't know. Didn't have any visibility to that. There's anecdotal rationales we'll talk
I
later.
guess they opened DB rankings and they said, which one is the first NoSQL database? Oh, Mongo. All right, let's use Mongo. Nah, I'm just kidding.
But SQL Server's scaling to the nth degree story wasn't an answer that was sustainable. And customers who are working with Sitecore it's a Microsoft-like environment generally. So they explored every avenue that was open to them as far as SQL Server went, and they felt the long-term approach was to split off and get out of that relational database kind of block, because it just wasn't the right solution to that specific problem. I'm not sure, am I answering your question? Is there?
And I guess, I'm not a Sitecore expert. I'm learning from Grant, and I learned some stuff from this presentation. So he said about different use cases with Sitecore, right? And Mongo is optimal for these use cases. Flexible schema. SQL Server doesn't have that, or at least it didn't have it.
Yeah, not in 2009 when they were.
So most probably they choose a JSON-based database just for that, I assume.
Yeah. Any other questions?
Cool.
All right, perfect. That's time.
Thank you.
Thank you, guys.